Okay, we're going to do 16 right here. Once you recognize which inverse function you're looking for, write it down. I'm going to write it down where if we took the derivative of sine inverse of sine, we would get 1 over the square root of 1 minus x squared. Now, I don't like having the x there. And the reason why is because I feel like we kind of get confused when trying to do the problem. When trying to make this look like this so that we can take the antiderivative of it, I feel like if we left it as x, it's kind of confusing. And instead, I would rather say, instead of putting an x there, I would just say something. So inverse sine of something equals 1 over the square root of 1 minus something squared. So I need a something squared right there. So we gotta make it look like this. So first, let's do some algebra here. The first thing that I would normally do is I'd first want to get rid of that 4. I want that 4 to be 1. Okay, so let's get rid of this stuff right here. All this erasing. You don't need to erase it, just do it. Okay. So let's get rid of that 1. Now I'm just going to write this right here so we can mess with it. We're going to manipulate that thing right there. We want that to say the square root of 1 minus something squared. And so inside my square root, I'm going to factor out a 4. This is inside the square root. So I would have 1 minus 9 divided by 4 x squared. Now that one's kind of weird because normally when you guys factor, you're used to getting 2 clean numbers. But when I divide 9 by 4, it's not a clean number, so I'm just going to leave it as 9 divided by 4. So the next thing we need, the next thing I need to remind you guys about is this guy. You guys remember, like, if you had the square root of a and you multiply it times the square root of b, that equals, what does it equal? A square root of ab, right? So what that means is if you had 2 numbers multiplying to each other inside a square root, we can separate it to look like this. So we can separate this to say the square root of 4 times 1 minus 9 over 4x squared. Okay, is everybody cool with that? Now we got that 4 added there. The 4 is gone, and actually we know what the square root of 4 is, which is nice too. What's the square root of 4 is? 2. Okay. So now I need this to say something squared. It needs to say something squared. Right now it says 9 over 4 multiplied by x squared. I don't want that. I want something squared. So what I like to, the question I like to pose to you guys is, what can I square to equal 9 over 4 x squared? What can I square? What would go inside of there? Yeah, 3 over 2x. Now this one actually, it looks more obvious than other ones that you might see. It doesn't have to be really dirty looking. So I can write this right here like this, and then we have what we want. This becomes, let's see, let's write it right underneath. We'll have a 2 in front, and then we'll have a 1 minus something squared, and that something is going to be 3 over 4, 3 over 2x. Is that correct? Is that good? Okay, so that's a bunch of algebra that we just did to manipulate. Now let's write our integral out and see what that does for us. So if I write my integral out, it's going to look like, it's going to have this little integral sign that's actually a stretched out s, and we have 1 over, and then we have a 2 out in front, the square root of 1 minus something squared, and that something is, that's not big enough for my something, I have 3 over 2x, and I'm going to square that. Okay, and then we have the dx. Now we like this. This looks very, very, very similar to this right here. I got to get rid of that 2, which is just a 1/2, right? So I can take out that 2 and put the 1/2 right out here, right? We're all good with taking the scalar out. And now I have 1 over the square root of 1 minus something squared, which is what we want right here. Now that's a something right there. This is when you're going to bust out u substitution. So let's make a u equal 3 over 2x. So what would the derivative of u equal? Well, it would be du over dx, and then we would get just 3 over 2 right there, correct? Okay, let's put the dx on the other side. And now I know what du equals, but let's get dx alone. So if I get dx alone, that would be like dividing both sides by 3 over 2, which is the same as multiplying both sides by the reciprocal of 3 over 2, so it's 2 over 3 du. Okay, is everybody cool still? Okay, I'm going to sub out this and this with what we have. So it's going to look like this. We have the 1 over 2 out in front, and then I have the integral 1 over 1 minus u squared. Oh, this is great. This is really good. Now it looks exactly like what we have up there. Oh wait, when I take out dx, what does dx equal? Dx equals 2 over 3 du. So I'm going to put 2 over 3 du. Oh, but wait a second. I'm just going to end up taking this out and multiplying by this guy, right? Yeah? So those 2's would cancel out, and you'd be left with? Okay, so I guess I can clean it up one more time. 1 over 3, then we have the integral of 1 over 1 minus u squared, and then we have the du right there. Now this is identical to this. Sweet. What is the antiderivative of that? Yeah, arcsin. Or you can write sine inverse. I think our answers say arcsin though, which is the same. It's fine. 1 over 3 multiplies to it. The 1 over 3 comes out of nowhere and just multiplies to it. But then, oh yeah, don't forget your plus c. And then, oh, and one more thing. Man, that plus c, guys. If you ever have to do the antiderivative on an FRQ, make sure you have the plus c. Okay? Don't forget that plus c. And multiple choice, you don't have to worry about it because you're going to look at multiple choice and go, oh yeah, the plus c. Just slap it on there. But on like FRQs, you're not going to remember that by looking at like there's no answers to look at. So make sure you don't forget that c. So let's sub in what u equals, and then we're finished. U equals 3 over 2x, or you can say 3x over 2, it's fine, and plus c. And that is our answer. Where is that guy? He's right here? Yeah, there he is.